Hello everyone, it's Mike Levin. Friday, July 15th. Close to 9:30 a.m. Getting a late start, but I had some sleep to catch up on. I really pushed myself hard recently on a project where I was connecting some very diverse dots, different types of programming that I've been doing for a while now, combining together into a single spectacular project whose end result seems to be something that has very little to do with the process it took to get there, but nonetheless the end result is an artistically shaped piece of data to help, say, navigate a site that used the input coming in to determine what that navigational hierarchical structure should be. Just a really fun and I think worthy Python / data science / SEO project. And I guess I'll be documenting bits of it here and there, but I want to keep this rhythm going that I've developed of talking about what will be the day's work, shooting a video of doing that talking, and then when getting into the office, either first thing in the morning making a talking head coding video, or later that day after having actually applied the thing I was talking about in real life to a project, I could then shoot the video towards the end of the day with the experience, almost the practice, such as it were, for the new video under my belt. And so what I will be doing today probably is putting some meaning to all these lists that we've been processing. So much of Python is processing, I mean, the simplest way to call them is lists, but really they're of all different shapes. Sometimes they're name value pair dictionaries, sometimes they're bundles of information in tuples, and sometimes they're unique, so they're sets, and sometimes the name value pairs are optimized for fast lookup as in a traditional dictionary, or sometimes they keep their order that they've been inserted with having a little bit more overhead. They were, I guess, subclassed from a more complex data structure, and they don't have quite the efficiencies, I believe, of the just plain dict, but it does keep its order. So there are so many different types of sequences in Python, each one having its own nuances, the way you use it, and its own API. And Python has type conversions, so whenever a type can be converted from one to another fairly simply, usually all you have to do is wrap it in that function, such as an ordered dict around a normal one, and it will turn the normal one into an ordered one. Although I do believe my discovery from yesterday is that you want to create the sort order at the very moment you create the ordered dict. An ordered dict is not something such as a list where you can just call sorted on it at any moment and bam, you've got it in its new order. The whole point of an ordered dict is to remember the order in which things were put in. Now, I have this added complexity in the work I'm doing that it's not just an ordered dict, it is a nested ordered dict. So there are objects within objects within objects, essentially built like a linked list in order to imply navigational hierarchies of unlimited potential shape from just this, object that has two connectors on it. Well, I don't even know if that's true. It's all an object needs to know is what its parent is, because it in turn can have children, but it doesn't need to know about its children because the child object is the thing pointing back to some unique idea of its parent. So in this way, we've got arbitrarily nested shapes And of course, I'm talking about something that can be represented here as JSON objects. People are used to this kind of data all the time these days because it's passed around so readily on the internet as pure JavaScript to be instantiated as an object and instantly have that in memory for your JavaScript programs to access and manipulate. And that has rapidly taken the place of XML, which was the previous popular, I guess, commonly accessible technique, protocol, data structure to do this sort of nested data. Because before that, the internet was not mainstream popular, and systems like EDI, electronic data interchange, were only for big companies with staff to do this sort of stuff. Now it's for, you know, middle school students doing homework projects. It's pretty amazing, really. And so I've got to first create these nested shapes from a flat shape, from a spreadsheet, tabular data. So it's worth making a point here that there are always two sides to these equations, different approaches to solving problems, each of which have different criteria and different benefits. One of the big granddaddy classics is static versus dynamic at execution time. These are some very misunderstood terms. Everything is dynamic, right? Because things move and change. Well, the point is, and it can really be summed up in the eval statement, there are other ways of looking at it, but the question is whether code can make code or not. Code that can make new code while it's executing. In other words, a program can create a data structure which is immediately put back into the program space from which instructions are being drawn so that it can make another program. This is inherently how things like LISP, the language that came out of MIT in the 60s, was designed for deliberately that meta capability, the self-referentiality, the blurring of the lines between stored data and data in running memory, which is about to be loaded to issue instructions. They're subtly different, and there's some different computer architectures out there that draw either sharper distinctions between the two, creating lots of, you know, long-term persistent memory like hard drive space, and not drawing the distinction and putting everything into some sort of universal memory that programs can be run out of, right back into, and if you lose power, it's not gone. You turn it on and it's back. Someday in the future, it may be economic and realistic to combine slow, static long-term memory, like flash memory and hard drives, with fast, close to the processor, ready to be moved in and out of register, RAM memory, DRAM. There's all kinds of words for it, but basically it's yet another example between a big split between things. There's static or compiled programs that run mostly the same way and can't use things like an eval statement inside of them to make new C code. Very rare. And then there's languages like the standard implementation of Python, which is a dynamic language which can very readily create new program structures in memory, which then in turn execute, creating things that have potentially runaway memory, security risks, the works. And it's really fascinating because people seem to divide up into these two very polarized groups. Those who think eval is evil, and those who like a little bit of power when they need it. And dynamic languages are just inherently more powerful. Without code that can create code, you can't create whatever, genetically evolving algorithms that get better over time, which is why you'll hear so many people talk about the LISP programming language being the most likely path to artificial intelligence, because it's designed to work, you know, much like the brain itself works, at least as far as we know. And where I was going, the splitting into the two significant groups. Oh yeah, in data structures, the big war these days is between tabular data and relational databases and Excel, everything spreadsheet, versus arbitrarily hierarchical nested data of arbitrary data types and inconsistent formats. So in tabular data, because of the way things load into memory, spinning through a row at a time, allocating resources, the amount of resources that it needs, it knows it's going to need for that row, using it, releasing it when it's done, plowing through it fast. And that's where you get things like the old Fortran language, which has somewhat evolved into the NumPy library for Python, which is probably now best known as the Pandas data science package, behind driving a lot of the popularity of Jupyter Notebook, which I'm talking about a lot. And tabular data, that's one approach. X by Y, rows and columns, cells, static, potentially statically defined data types. But just because it looks tabular doesn't mean it is. There could be data going off in other dimensions. Multi-dimensional or n-array data types are possible. Those can also be static because even though it goes off in other dimensions, the amount of data along that dimension can be predefined as well. But then there's all these reference tricks that Python can do, such that if you have a list and you've got integer, 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 bam, you can have a huge text data type, a huge string there. And that's perfectly legit in Python, but it slows down execution, which is why if your programs are written a certain way, they compile really well under PyPy, the very C compiler-like version of Python that can give you a times 10 or a times 100 increase in speed by just recognizing these places where you're using dynamic data types as if they were static, does the internal conversion, and your now compiled Python code runs much, much faster. But then the nested hierarchical people are really having their day, and that is the keyword there is NoSQL, of course, and all these various databases like Couch and Mongo and Redis, and even those come in many flavors, being whether they are ACID or BASIC, I guess that'll be another video, but also whether they encourage you to think about the data as arbitrarily nested, like Mongo does, or whether they encourage you to think about it as name-value pair, as Redis does, or Berkeley DB. And the point of everything, though, is that these two worlds are not so distant as they seem. They are both arbitrary mental constructs. They're APIs around your data that you use, and everything is flat. It's linear. It's written to some surface media like the spinning hard drive or the X by Y, matrix arrow of transistors on integrated circuits. There's really no such thing as truly hierarchical data unless you're like arranging molecules hierarchically in the physical world, or arranging, I don't know, some sort of real world physical thing. Then you'll have hierarchy. In the information world, it's all just pointers pointing to pointers pointing to pointers, either trying to keep things continuous on the media, thus fast, or allowing it to jump all over the place with a sort of random access or nested hierarchies of arbitrary size, mental framework around it, API. So the trick is to be able to elegantly and knowledgeably switch back and forth between these two worlds. And I had a project recently that did it in the most baby step way possible, in that I had to look at tabular data and build a hierarchical shape that it implied out of it. So precisely and cleanly that it could be that the data that I produced could be loaded as the data into these CSS and JavaScript menu libraries, navigational libraries, things like Twitter's Bootstrap or AngularJS or YUI or one of the many other things that can build widgets around your data. In the one case, to make it not search friendly but work with the majority of libraries out there, I would do the transformation into JSON data from my clearly Python native object shapes of the nested ordered dict, which will be the subject of my work today, or you output it as an unordered list with line elements, a nested unordered list, and you will allow pure CSS to make it look like a expandable and collapsible drop-down menu, which is my preference, of course, because that kind of code can be put into the view source of the website and be search optimized. Google can see those links without having to read the JSON, infer its meaning, etc., etc. You just use normal, UL and LI elements with hrefs in the right spot, and it's all just normal HTML representing the hierarchical shape. So anyway, I got to the end of what I needed to talk about, and I'm not even at work yet, so I'll give my arm a little rest as I finish this walk. So hope you join me later today when I do the tutorial regarding either the turning these lists into something meaningful, like parsing out email, that's one project I'm considering, or doing the transformation from the tabular data to the nested hierarchical data. That's the other possibility. So join me then, and as usual, thanks for joining me. Don't forget to thumbs up the video. Hope to see you again soon, and don't forget to subscribe.